Welcome, Algebra 2 students. We are covering Lesson 90, Systems of Three Equations. This is in your Saxon Algebra 2 textbook on page 374, and you will want to have your lesson notes on hand as well. When we're solving three equations with three different variables, the first thing we're going to try to do is look at our equations and choose a variable that we can eliminate from all three equations relatively easily. So choose a variable to eliminate. Okay, so when I look at these three given equations, I am going to decide to get rid of my y value in each equation. The reason I'm choosing that is if I'm looking at my y value here and here, they already are set up to cancel. And then in addition to that, I can easily set the first two to cancel using elimination and multiplying a 2 through that first equation. So I'm going to use the y variable as the one that I'm eliminating. All right, so I'm going to rewrite this first equation, but I'm going to multiply everybody by 2. So this is the first equation multiplied by 2. Distributed a 2 all the way through. Okay, and then I'm going to take the second equation and I'm going to write it just as we see the second equation. Not making any alterations, just copying it over. This is set up now that I can add straight down. And you'll notice that the y values will cancel. I'll go back and add everything else. Okay, that's the first step. That used equations 1 and 2. Now I'm going to focus on equations 2 and 3 together. I don't need to modify anything. I'm just going to copy down equations 2 and 3 because they will cancel out the y values. They're already set up. One is a positive 2y and the other one is a negative 2y, so they are set up already to cancel out y. So as I set them up here, I notice the y's cancel, and I add straight down. I get 2x plus 2z equals 8. Okay, now I'm going to focus in on combining these two new equations. I need to look at this equation over here and this equation over here, and see if I can find a way of using elimination to cancel out either the x or the z. And I think I'm going to go ahead and try to cancel out my x's. If I were to multiply one equation by 5, so if I multiply this equation by a 2, this equation by, let's say, a negative 5, then I'll end up with a 10x or a negative 10x, and they will cancel. Okay, so I'm going to write down what these new equations would be. So coming from here, multiplying by 2, (10x plus 14z equals 52. And then if I take this one over, multiplying by a negative 5, I get negative 10x, negative 10z equals negative 40. That's ready for me to add straight down. And once again, you'll see I have elimination set up properly. The x's get canceled. The z values, when I add those together, I get 4z equals 12. Divide both sides by 4, and I get z equals 3. Okay, so that part of my solution is done. I'm just going to highlight it so I remember that later. And now I'm going to go back and see what I can do with that information. I can take z equals 3 and I can apply it to either of these more recent equations in order to solve for x. So I'm looking back at one of the more immediate equations. I'm going to plug in 3 for z and I'm going to solve for x. Okay, so I'm going to choose this equation right here and I'm going to plug in for z. I have 2x plus 2, plug in 3 equals 8. Go through and use your algebra skills to simplify that. Subtract the 6 over. And I get x equals 1. Okay, now my final step is I still need to go back and I need to find y. And the value for y, we need to go back to one of the original equations from the very beginning. Okay, so when I look at those first 3 original equations, I can choose any of them. I think the second equation or the third equation looks a little bit easier. I'm going to rewrite the second equation. Just rewriting it as I see it over here. And then I'm going to plug in my new values. So x is now 1. Y, we don't know, we're solving. Z is 3. Use some algebra skills to combine like terms. And I get down to y equals 2. Okay, so once I have that solved, my final answer, if I want to put all 3 of them together neatly, is to put them in order of x, y, z, x, y, z. And that is how I would submit that answer. Okay, moving on down to the practice question from your book. This is on page 375 at the bottom of the page. If it's not already copied down for you, you'll need to copy that down. Let me take one moment to do that real fast. And as you're looking at the problem, start thinking about which variable looks like an easy one to eliminate, and make sure it's going to be good for all 3 equations, that you would eliminate that same variable in all 3 equations. So you're looking for the ability to use elimination across that variable a couple different times. Okay, so first thing I noticed is if I look at the first equation and the second equation, that I would actually be able to eliminate both y and z just by multiplying 2 to the second equation. So I'm going to do that over here to the side. I'm going to multiply by 2. And the distribution of 2 across that gives me 2x plus 2y minus 2z equals 6. Okay, and then rewriting the first equation just as we see it, x minus 2y plus 2z equals 2. Now it's a little bit of a bonus that I found that 2 different variables are going to cancel on my first try. So you'll see as I go to add straight down, the y's are going to cancel and the z's are going to cancel. So I really am only focused on the x right now. Add those together and I get 3x equals 8. And you may be wondering, is it possible I get a fraction? Yes, Saxon thinks that will be fun for you. X happens to be a fraction. Okay, Now I'm going to go back to the second equation. I'm going to plug in that x value to the second equation and be left with just y and z. Okay, so I'm going to go back to equation 2, the original equation 2. I'm going to plug in my new x value as 8/3. And I'm going to solve by bringing the 8/3 over to the right side. In other words, I'm subtracting 8/3 from both sides. And if you're not feeling real savvy with your fractions, I'm going to get you started here. Y minus z equals 3 minus 8/3. That's actually going to come out to 9/3 minus 8/3, which is 1/3. Okay, so we didn't solve anything. We just kind of rearranged some. We're ready to go to equation 3 now and do the same thing. Okay, I'm going to look at the original equation 3. I'm going to plug in 8/3 for x value. Go through and simplify that. That makes the fraction actually go away. Move the 8 to the other side by subtracting it to the other side. And I can go one step further. I can divide everybody by a -2. All right, and that would produce y plus z equals 3. Okay, so now I'm going to take those two equations that we just had and I'm going to bring them together so that we can use elimination again to narrow down a variable. So I'm going to write them over here. And you'll see the z's are stacked up so that they cancel. So I'm going to add the two y's together. And I'm going to add 3 plus 1/3. If I want to make that into an improper number, that's going to make life easier. So I'll rewrite 3 1/3 as 10/3. And then I need to divide the 2 to the other side. So I would get 10/3 times 1/2. And then after reducing, I get y equals 5/3. Okay, so I have my x, I have my y. I still need to go back and find my z. So I'm going to scooch over here. I can use either of the equations that we were just working on here to plug in my y value and solve for z. So I'm going to use this top equation and I'm going to plug in 5/3 for y. You might be able to mental math that and say 5/3 minus what is 1/3. If not, you'll subtract the 5/3 over. Ultimately, you should get down to z is equal to 4/3. Okay, so now I have all three solutions and I'm going to write it in my ordered trio, my x value, my y value, and my z value as my final solution. Okay, so that's the notes portion. We're going to go over to the actual homework problems now. And we're going to start with question 6 from the homework. In your book, we're on page 376. I'll take a moment here just to write down the problem. Start looking for which variable might be the best one for elimination. Make sure it's going to be good for all three equations. So it looks to me like the x is set up perfectly for elimination. I have a positive and a negative x. So I could actually take these first two equations and work with them. If I were to add those first two equations together, my x's cancel. I have a y plus a negative 2y, so that comes out to be negative y. A negative z and a negative 2z, that comes out to be negative 3z. And adding 3 and 0 together at the end. So I kind of shortcutted it there, but I have just the first two equations added together. And then if I do the same shortcut for the next two equations, I have equations 2 and 3 added together. X's cancel. My y values together would become negative 4y, negative 4z equals positive 4. Okay, and then I don't have it set up for elimination when I have my purple and red together. But what I can do is rewrite this purple very easily by solving for y. Okay, so if I solve for y on the purple, first thing I'll do is add the 3z over. And then I have to get rid of the negative. So I get y equals negative 3z minus 3. And the reason I solve for y is I'm going to use substitution and plug it in. So back to my red equation. Instead of y, I'm going to plug in negative 3z minus 3. I have a negative 4 that's going to get distributed. (12z) and negative 4z together will make 8z. Subtract that 12 to the other side, I get negative 8. And therefore, z is equal to negative 1. All right, so now that I have z equal negative 1, I'm going to go back to that purple equation, and I'm going to plug in my z value as negative 1 and be able to solve for y. And it looks like y is going to zero out. And then my final step is to go back and find x. So I could use the very first equation from the original problem. I'll write it down here, and I'm going to plug in. I know that y is 0, and I know that z is negative 1. And I find that x is going to be 2. So when I put these all together in my x, y, z form, I get 2, 0, negative 1. And that's my solution. I'm going to head over to do number 7 next. Copy this down. Take a look at what variables might easily be able to cancel. Oops, back there. And I think I'm going to go ahead and eliminate the y values. It's similar to one of the practice questions we did. I can use a 2 distributed across the first equation, and that will eliminate the negative 2y and the positive 2y. So I'm going to start with that. I'm going to multiply the top equation by a 2, and I would get 4x minus 2y plus 2z equals 4. The second equation, we're just going to keep it as it is. X plus 2y plus 2z equals 3. Okay, and then we're ready to set up here for elimination. Add straight down. And I get kind of an ugly equation there. Now I'm going to head over to equations 2 and 3. And if I look at 2 and 3, they are set up already. I'm just going to sneak over here and add 2 and 3 together because the y's are already ready to cancel. So I get 3x plus 3z equals 3. Okay, I can set this up for elimination with my blue, or I could use substitution. I'm going to go ahead and do substitution. We haven't used it as much. Excuse me. So we have to get either x or z by itself. Let's move the z over and then divide everybody by 3. And I have x equals 1 minus z. Now I'm ready to sub that in to the blue equation where I see the x. So instead of x, I put 1 minus z, go through, solve it algebraically, distribute that 5 across. Okay, and when I combine those together, I get a negative z. I subtract the 5 over, and I get positive 2. Negative z equals 2, which means that z must equal negative 2. Okay, so I have my first one solved. Now I'm going to go back to one of my more immediate statements. I think actually I'm going to go over here and solve for x now that I know what z is. Okay, so x is equal to 1 minus, instead of z, I'll plug in negative 2. So x is really equal to 1 plus 2, and therefore x is 3. I have my x, I have my z. In order to solve for y, I'm going to have to go back to one of my original equations from the very top before I eliminated y. So I'm going to use the first equation and rewrite it down here. 2x minus y plus z equals 2. Then I'm going to solve by plugging in x is 3 and z is negative 2. So 2 times 3, combine 6 minus 2, and then subtract that 4 over. I get negative y equals negative 2, which means y must equal positive 2. I take all 3 of those answers to combine them. So my x was 3, my y is 2, my z is negative 2. And there's my solution. Okay, and we're going to do one more question. It's from number 4, so that you have a chance to watch the chemistry type question done on video. Okay, so you need to look in your book on page 376. And it reads, only 10% of the first solution was glycerine, but 40% of the second solution was glycerine. How many liters of each should Lolita use to get 800 liters of a solution that is 13% glycerine? So the first thing I'm going to do is identify what these columns and rows should be. Okay, so we typically put our percent of whatever it is we're talking about, and I'll just abbreviate, we're talking about glycerine. We usually put that in our first column. Then our next column is the unit of measurement that is used, such as liters or milliliters. In this case, it's just liters, and we use a capital L. On the far right, we can just write total. Okay, and then I'm going to come down to the rows. The first row, I can just call it my mix 1. My second mix, mix 2, and then my final mix. And then I'm going to gather information from the question. So the first sentence kind of helps us guide through the first mix. It reads 10% of the first solution. So I'm going to come into the 10% under the percent glycerin. The second solution had 40%. And then we look at what is it we want in our final solution, and our goal is 13%. The other information that's provided is the final solution is going to have 800 liters. Okay, so most students can get to this part, and this is where it gets tricky. We don't have information about the amount of liters for mix 1 or mix 2. Okay, so we're going to have to put a variable, but we don't want to use two different variables. So I'm going to go ahead and call mix 2 x. And guys, it doesn't matter. It could have been mix 1, but I'm going to make it mix 2. And since I know that that is x, mix 1 would be everything else. How I write that is the 800 final solution minus the x. Okay, so that's everything else. Then I'm going to distribute that across. I take the glycerin and I distribute it to the liters. So in other words, the 10 gets distributed to the 800 minus x. The 40 gets distributed to the x. The 13 gets distributed to the 800. And I make an equation out of this. I take mix 1 and I distribute the 10, and I get 10x. Oh, actually, let me back up. That might be confusing because I did it out of order. I would do 10 times the 800 first. So that's 8,000 minus 10x. Now I add the second mix, which is going to be 40x. And 13 times 800, which is 10,400. Go back and find your like terms. So I have 8,000 plus 30x equals 10,400. I'm going to subtract the 8,000 to the other side. And I get 2,400. And then I need to divide by 30 on both sides. I get x equals 80. And I can't just box that in. I have to figure out what that means in the context of this problem. So my x value, guys, up here, that is mix 2. So what I just found was mix 2, and how I write that in a solution is I'm going to say 80 liters. I know that again because it was liters that we are using. 80 liters at 40%. And that's brought over here. And then how do I find the other liter? Well, I would need to think about subtracting 80 from 800. So the other one is going to be 720 liters, and that's at the 10% solution. So those are the two solutions for that. All right, good luck.